The torque generator of William F. Skinner is an interesting device. In 1939, which was the start of World War II, William Skinner of Miami in Florida demonstrated his fifth generation system, which was powered by spinning weights. His demonstration can still be seen on the web, where he shows its design powering a 12-foot lathe, a drill press, and a power hacksaw, all at the same time. The newsreel commentator states that the output power was 1200% of the input power. Now that's COP equals 12, but it's highly likely that he should have said 1200 times rather than 1200%, because he then says that if you put 746 watts of input power into the device, it could power 3,500 homes. Now if it were COP equals 12, then each of those 3,500 homes would receive less than 2.6 watts, which is clearly wrong. At the much more likely COP equals 1200, each household would receive on average 255 watts, which might just be possible in 1939 when few appliances were electric. Anyway, Skinner's impressive equipment was being driven by a single cotton thread loop powered by a 1/8 horsepower, which is 93 watts, electric motor, and it was powering his whole workshop, and it looked like this. There are various weights and various drive shafts, and the output power is taken along a drive belt to the rest of his workshop. The design has 4 nearly vertical shafts, each braced to give extra rigidity. These rotating shafts pass their rotating power to the mechanical output drive belt. Now each shaft has got 2 weights, and the pairs of weights spin 2 or 3 times a second and produce the whole of the output power. This is one of the large upper weights, and this is the top of one of the long lower weights, which is about 3 times as long as the upper weight. As far as I'm aware, Skinner never patented his design or disclosed how it worked. However, the operating principle is very simple indeed, although it may take you a while to grasp how it works. You can check this out for yourself quite easily if you have access to an old-fashioned chair with 4 rigid legs, something like this one. If you tilt the chair over so that it's balanced on one leg, you will notice that there's almost no effort needed to keep it in that position, as all of its weight is supported by the floor through one of the legs. Now move the top of the chair by a very small amount and keep it in that position. You will notice 2 things. First, very little effort was needed to make that move, and second, the chair now swings round and becomes stationary under the new position of the top of the chair. Notice 2 other things. The chair swung round because of your moving the top slightly, and you did not swing the chair around. If the chair is heavy, then the amount of energy that the chair generates when it's swinging around is very much greater than the amount of energy which you use to move the top of the chair. If you keep moving the top of the chair in a tiny circle, the chair spins round as long as you keep moving the top. The amount of energy in the spinning chair is very much greater than the energy needed to make it spin. So where is that extra energy coming from? What is happening is that the chair swings round under gravity, but before it gets there, underneath the new point, you move the top of the chair further around, and so the chair has to swing further. But before it gets underneath the top again, you move the top further. No matter how heavy the chair is, very little effort is needed to move the top. Try it for yourself if you don't believe me. William Skinner had a mechanism at the top of each of his vertical shafts, and that mechanism kept moving the top of the shaft in a small circle, while allowing the shaft to rotate freely at all times. While Skinner used a motor of about 100 watts, very little of that motor power was actually used, as the drive band was just a single loop of thread. Skinner's design looks complicated, and that's because he kept redesigning and improving his device over and over again. I think that the first thing that he found was that if he kept increasing the size of the weights in order to increase the output power, that the whole structure wobbled. So he added a second shaft to balance out that wobbling effect. Then it occurred to him that he could add another 2 shafts to make 4 in all, and that would double the output power. Then it occurred to him that moving the top of a shaft would be easier if there was an inverted balancing mechanism above the top, and this is why the design shown in the video is his 5th version of his design. It's not necessary to try to replicate Skinner's 5th version, as his first version is probably quite enough to be useful. I have not built one of these, so what follows is just my suggestions about building something which might be useful. I would suggest something like this, and this has a single vertical shaft with a heavy weight on it, and the top of the shaft is moved round in a small circle by a little motor, and the motor is under the control of a speed control, which is a simple commercial device readily available. The bottom of this slightly slanted shaft goes into a universal bearing, so that it doesn't matter that the shaft is moving around at a slight angle. The weight rests on a thrust bearing, and the shaft then goes through to a gearing system which drives a 12-volt generator, whose output then goes as a power supply through to drive the motor rotating the top, and to supply excess output power to other things that you want to use. The objective is to spin a generator to produce an output which is large enough to power the unit and provide useful excess electrical power to operate other equipment. Now for this we can build a simple frame. The suggested materials and dimensions are covered in the ebook, which is at www.freeenergyinfo.com/pjkbook.pdf. But the suggested construction is very simple. You connect pieces together in this general form and general format to create a structure which is both simple and yet is rigid, and to that you attach the bits and pieces that you need to make the system work. Now we need a cheap and readily available serious weight to be spun around, and those are available as exercise equipment, and quite cheaply as well. They can be mounted on a strong arm arranged like this. I suggest that this lever arm is made from steel, but that's certainly not essential. There's a feeling that a spinning weight will cause major sideways force, like this, but that only happens when the weight is being swung around by the shaft. In this case, the weight is always falling under its own weight. This is actually quite difficult to understand, as the normal reaction is that for something to fall, it has to get closer to the ground. But in this case, the weight is continuously falling, but it falls sideways rather than straight down. To get the top of the shaft to rotate, a small motor can be used. This is a geared down motor. It's low cost, low power, and is readily available. The motor can turn a small arm which attaches to the top of the drive shaft. The arm looks like this. You have the motor at the back powering it. The shaft of the motor is clamped to the actual bar, and the drive shaft fits into a hole drilled into the crossbar. There's no need for a bearing where the drive shaft fits into the drive arm, as the angle between the bottom of the drive shaft and the top of the drive shaft and this particular arm is pretty much fixed. The bottom of the drive shaft rests in a thrust bearing and has a universal joint which passes the turning power of the slightly angled drive shaft through to the electrical generator. The speed of rotation of the top of the drive shaft can be controlled using an ordinary DC motor speed controller module. They're readily available commercially and very easy to get. The starting speed of the shaft can be ramped up very gradually from stationary to the desired speed you want for any given operation. The best generator to use with something like this is probably one intended for use with a wind-powered system, because they don't spin as fast typically. This one has a three-phase output, and while that sounds a bit daunting, it's easily handled just by using a three-phase diode, which is like this. The three-phase diode has got three inputs for AC, or three outputs for AC, and the output then goes to each output goes to a pair of diodes, which gives a plus and a minus connection. And the little module itself is quite simple to use. You have three connections which are marked for alternating voltage being applied to them, and two tabs for connecting with a plus and a minus output. Three-phase wiring is generally used because it's more efficient than the more familiar single-phase systems, and it can be connected like this. The sloping shaft spins the generator itself. The generator's three outputs go to the rectifier diode. The plus and minus from that go to a box holding the DC motor speed controller with its on-off switch and its speed of rotation control knob. And then the output is fed to the motor at the top, which actually rotates the top of the shaft. However, the faster the generator is spun, the greater the electrical output. So gearing up the speed of that shaft rotation is a good idea, and bicycle gearing can be used for that. It's used, of course, in the reverse direction, because the large sprocket arm, or sprocket disc, or sprocket wheel, is attached to the drive shaft, and the small one, which has fewer teeth and therefore rotates faster, is attached to the generator shaft. And that speeds up the rotation of the generator and produces better power from the system itself. Now, to get the system started when the generator isn't rotating and there's no output from it, you use a small DC battery, which could be a battery box with 10 1.2 volt NIMH AA size batteries, because the nickel manganese batteries are very powerful and lightweight and cheap. That gives a 12 volt supply, which with a press button start switch will get the speed controller working and will drive the top of the shaft round at whatever speed you set. This is quite an effective system as such, but please remember that this is only a suggestion, and I personally have not built and tested a unit of this type.